Hello, my name is John Kyler Zeno, and this is EGR 214 Numerical Methods for Engineers. This is taking place in the spring 2023 semester with the instructor being Dr. Hans Chapman. This is my final project, and my final project will be a MATLAB tutorial solution manual for volume integrals, with the related course being Calculus 3. Now, the use of volume integrals in real life, or triple integrals, they are used to find the volume of a bounded region on a three-dimensional graph containing the x, y, and z planes. Now, the formula for the volume of a closed region is going to be the capital V is going to be equal to the triple integral with the bounded region being capital D with respect to dV. Now, dV in this case is normally going to be a given equation with all the examples I'm going to show, and then capital D is all the bounds with respect to x, y, and z. So now the script file. My script file is going to be used to find the volume of a bounded region on a 3D graph. Integral 3 is the MATLAB function to perform a triple integral. Fun is short for function, which will be a given in each of the example problems. And you're going to be told to input the given function with respect to each variable, which in this case is x, y, and z. Then the lower bounds, or x min, y min, and z min, are the minimum values of x, y, and z. You're going to be told to input the minimum values. Then the upper bounds, or x max, y max, and z max, are the maximum values. You're also going to be told to input these. Then you'll be given the volume, which will be v, in this case, is going to be equal to integral 3, which is the function, and then fun for short, which is going to be the given example, and then the lower and upper bounds, and then it's going to display the result of the volume. Example problem 1, you're being told to find the volume of the given problem. In this case, there's going to be the triple integral with all the bounds going from 0 to 1 of x squared plus y squared plus z squared in the order of dz, dy, dx. And as you can see from the picture, in this case, this equation is actually a sphere. So the analytical solve for example problem 1 in this case is going to be this handwritten work I've put up. It's going to be the triple integral with all the bounds going from 0 to 1 of x squared plus y squared plus z squared in the order of dz, dy, dx. Now, in case anyone doesn't know how triple integrals work, it's just a simple one integral, but you do it 3 times, kind of obvious. But in this case, as shown on the right side, first integral we're going to take is going to be with respect to z, or dz. So when you do that, you just input a z into each of the variables. So you have a double integral, both bounds from 0 to 1, of x squared times z plus y squared times z plus 1/3 z cubed, with the bounds being from z equals 0 to z equals 1. And obviously, because each of the variables have a z attached, if you plug in 0, it all goes to 0, so that is redundant. So you just plug in z equals 1. You're going to have the double integral, all bounds from 0 to 1, of x squared plus y squared plus 1/3 with respect to dy, then dx. So then you repeat the process. Next time is second, so you do with respect to dy. Repeat, so you have just a single integral from 0 to 1 of x squared times y plus 1/3 times y cubed plus 1/3 times y. Bounds being from y equals 0 to y equals 1. Once again, 0 is useless because each of the variables has a y attached. So you plug in these bounds. In this case, only 1 is needed. So you'll have the integral from 0 to 1 of x squared plus 1/3 plus 1/3, which then goes to the integral from 0 to 1 of x squared plus 2/3 dx. Take that last integral, you're going to have 1/3 x cubed plus 2/3 times x, and 0 to 1. Once again, 0 is useless, so you're just going to plug in 1. Then that will go to 1/3 plus 2/3, which is then equal to 1. So the volume is 1. So now for the numerical solve. In this case, the script file is named volume underscore trip for triple underscore int for integral. So once you run this script file, you're going to be told to enter the given function. As I said, it has to be with respect to the variables, so you have to put the @ and then inside the parentheses all the variables, in this case x, y, and z. Then you just type in the given function. In this case, it's x squared plus y squared plus z squared. Then you're told to enter all the minimum values. In this case, they're all 0. Then you're told to enter all the maximum values. In this case, they're all equal to 1. So once you do that, it spits out the volume, and the volume in this case is 1.00 cubic units, obviously depending on the units you're told, but in this case we have none, so it's just 1. Now for example problem 2, we're told to find the volume of this given problem. It's going to be the first integral from -1 to 1, then 0 to 1, then 0 to 2, of x plus y plus z in the order of dy, dx, dz. As you can see from the picture, x plus y plus z is just a plane, but once you plug in all the bounds for, let's say, y equals 0 to 2, you have y equals 0 and y equals 2, you're going to have kind of left over with a cube area. So you're going to find the volume of that given cube with respect to the plane. So now for the analytical solve of example 2, you're going to have the first integral from -1 to 1, then 0 to 1, then 0 to 2 of x plus y plus z in the order of dy dx dz. So as last time, you just do the first integral, so you're going to do it with respect to y first. So you're going to have the double integral from -1 to 1, then 0 to 1 of x times y, plus 1/2 y squared plus z times y. The bounds are 0 to 2. Once again, 0 is useless because every single variable has a y attached, so that would all go to 0. So you just plug in y equals 2. Then you're left with the double integral of 2x plus 2 plus 2z, then in the respect of dx dz. So you take the second integral with respect to x. So you have the integral of -1 to 1, x squared plus 2x plus 2zx. From x is going to be equal to 0 to x equals 1. Once again, 0 is useless, so you just plug in 1. When you plug in the 1 bound, you're going to be left with the integral of -1 to 1 of 1 plus 2 plus 2z dz. That is going to go to the integral of -1 to 1, 3 plus 2z dz. Then you take that last integral, you're going to be left with 3z plus z squared from z equals -1 to 1. Plug in the bounds, it'll be 3 plus 1 minus -3 plus 1. That goes to 4 minus a -2, which is then equal to 6. Now for the numerical solve of example problem 2, once again you plug in the script file, so volume underscore trip underscore integral. You're told to enter the given function. Once again you have to put with respect to the variables, so @ inside the parentheses x, y, z. Then you just plug in the function, which in this case is x plus y plus z. Then you enter the minimum values of each bound. X is 0, y is -1, z is 0, then the upper bounds or the maximum. X is 1, y is 1, and z is 2. Now as you can see from the script file, and if you looked at the previous problem, in that problem it was with respect to dy dx dz, instead of dx dy dz is the first one. Because of the script file, it doesn't actually matter the order of the variables, it still gives you the exact same volume, which in this case is 6.00 cubic units. My concluding statement for this project is that the purpose of the script file is to determine the volume of a bounded region on a three-dimensional graph with given bounds. Although these types of problems are relatively simple to solve by hand, the script file allows the user to find the volume much faster. Now this script file can only be used when the bounds of the integrals are real numbers instead of variables like x, y, and z. So this does limit the file, but it still finds the volume at a much faster rate than by hand. Because as you can imagine, my bounds are only from 0 to 1 or 0 to 2 or something very small. But as you go into higher numbers, like x equals 30 or z equals 27, it gets into much higher numbers. It becomes a lot more tedious to solve by hand, and having a simple script file that can do it in a split second is much more useful than anything else. So I hope you learned a lot today from my script file and my MATLab tutorial, and I hope you can use this to your advantage one day. Thank you.